our solar system might have a hidden planet called Planet 9. For a long time, astronomers have been trying to figure out why some objects in space are moving strangely. They're thinking Planet 9 might be the answer, but if it doesn't exist, we have a big mystery on our hands. This could change the way we think about the solar system and make us look for new reasons why these objects are moving weirdly. So we've only been studying the region of the solar system beyond the orbit of Neptune for a few decades now. It's easy to know why astronomy out here is kind of challenging. This is because the objects we're trying to hunt down are very small and very far away. That makes them hard to spot. The story of Planet 9 began in early 2016 when astronomers Mike Brown and Konstantin Batygin published a paper called Evidence for a Distant Giant Planet in the Solar System. In the paper, authors showed that there are groups of KBOs whose orbits are shaped in such a way that only the presence of another planet can explain them. While the orbit of most KBOs shows clear evidence of being shepherded by Neptune, on the other hand, several extremely distant KBOs don't represent that. Their orbits appear to be aligned at a distant point. They suggest that a planet about 10 times the mass of Earth could explain the unusual patterns observed. Their paper was partly based on the presence of Sedna, a minor planet first spotted in 2003. It is the furthest distance from the Sun, which has over 900 astronomical units. At the time, it was the coldest object that we knew of in the solar system. Its highly elongated orbit was first explained as a result of the gravitational influence of Neptune. But in reality, it never comes close enough to Neptune. But Sedna was just the beginning. It's one of a group of objects called extreme trans-Neptunian objects, or ETNOs. Eventually, more of these distant objects were discovered. Biden, or 2012 VP-113, was discovered in 2012. Goblin, or 2015 TG-387, was discovered in 2015. Then, in 2018, astronomers discovered Far Out, or 2018 VG-18. Each of these objects is further and further away. These distant objects hint that Planet 9 shares orbital characteristics in common. That's what this whole thing is kind of about. To be more precise, their longitudinal perihelions are clustered in what's called their orbital pole positions. Scientists conclude that there is only a 0.2% probability that this is random, so not very probable. In 2019, two new studies gave us new evidence in support of its existence. The first one is called Orbital Clustering in the Distant Solar System by Konstantin Batygin and Michael Brown. The second is the Planet 9 Hypothesis by Fred Adams and Juliet Becker, both from the University of Michigan. Several alternative explanations have been proposed to account for the observations that led to the hypothesis of Planet 9. One significant alternative is the modified Newtonian dynamics, or MOND theory. MOND posits that gravity behaves differently at low accelerations. This could explain the observed orbital anomalies without the need for an additional planet. According to this theory, the clustering of orbits in the outer solar system could be the result of the gravitational pull from the entire Milky Way, rather than from a hypothetical planet. Recent studies applying MOND to the outer solar system found that the theory aligns well with the observed data, suggesting that it could be a viable explanation for the anomalies typically attributed to it. Another proposed explanation is that the observed gravitational effects could be due to a distant disk of small icy and rocky objects, rather than a single large planet. This disk could exert the necessary gravitational influence on the Kuiper Belt objects to create the observed orbital patterns. Additionally, interactions between the known planets, sometimes referred to as gravitational bumper car interactions, could also produce similar effects. A more exotic hypothesis suggests that it could actually be a primordial black hole. This theory suggests that a small black hole could account for the gravitational influences detected in the outer solar system. While this idea is more speculative, it highlights the range of possibilities considered by scientists. These alternative theories illustrate the complexity of interpreting astronomical data and underscore the ongoing debate about the true nature of the forces at play in the outer reaches of space. If Planet 9 does not exist, several current theories in astrophysics and our understanding would need to be revisited. In case the planet isn't responsible for the anomalies of TNOs, alternative explanations must be found. The techniques and methodologies used to search for distant planets would come under scrutiny. The potential selection bias in previous surveys could highlight the need for more comprehensive and unbiased observational strategies. Improved technology, such as the upcoming Vera C. Rubin Observatory, might provide clearer data and refine our search parameters for distant solar system objects. The existence of a large and distant planet would have implications for theories of planet formation and migration. Its non-existence would prompt scientists to explore different scenarios for the early solar system's evolution and the distribution of mass within it. The search for it involves advanced technology and innovative methodologies to detect this hypothesized object in the outer solar system. Astronomers utilize advanced telescopes such as the Atacama Cosmology Telescope and the Subaru Telescope in Hawaii. They are used to capture high-resolution images and detect faint objects far from the Sun. These telescopes have been instrumental in identifying trans-Neptunian objects that exhibit unusual orbital patterns. Data from space missions like the proposed Uranus orbiter and probe can significantly narrow the search area. The spacecraft would send positional data back to Earth during its journey. It could be analyzed for gravitational anomalies caused by Planet 9. This method is significantly more precise than previous attempts, such as using data from the Cassini mission to Saturn. Computer modeling helps predict its potential location and characteristics. By simulating gravitational interactions within the solar system, researchers can identify the most probable regions where the planet might be located. These models are continuously refined with new data from telescopes and space missions, directing observational efforts more effectively. Wide-field sky surveys are essential for covering large areas of the sky to identify any faint objects that could be Planet 9. These surveys use powerful cameras and sophisticated algorithms to process vast amounts of data. It filtered out potential candidates for further study. Projects like the Dark Energy Survey and the Legacy Survey of Space and Time, also called LSST, are crucial in this effort. The search for Planet 9 faces several significant challenges and limitations. It is expected to be extremely faint and far from the Sun. This makes it difficult to detect with current telescopes. It's possibly 20 times farther than Neptune, and its dimness poses a substantial challenge to direct observation. The hypothesized distance of 500 astronomical units means it could take thousands of years to complete one orbit around the Sun, making direct observation pretty challenging. Such an orbit could be inclined at a significant angle relative to the plane of the solar system. So, is there a Planet 9 out there or not? The truth is, the search for this mysterious world is ongoing. What do you think? Would you put your money on exists or doesn't exist? Let us know in the comments below, and don't forget to like and subscribe.